This video is about the area and circumference of a circle. It's found in your text in section 11-5. First, let's go through some definitions. The circumference of a circle is the distance around the edge of the circle, kind of like perimeter. The diameter of a circle is the distance across a circle, and the radius is the distance from the center to the edge, and this is half the diameter. Intuitively, you can convince yourself of that pretty easily. As we discovered on Pi Day when we measured our cookies, the ratio of the circumference of a circle to its diameter is always the same number, though we can never measure it with perfect accuracy using our measuring tools, or really any measuring tools. Perfect accuracy isn't attainable, but we give a name to this special ratio. The circumference of a circle over the diameter is pi. We can find an approximate value for pi using various methods, both mathematical and by using precise measuring tools. We will often leave our answers in terms of pi, meaning that when we do a problem, we'll come up with an answer, for example, like 6 pi, and we won't plug that into our calculators and try to find a value. If we need a number for a calculation, if we need to plug in a number for pi, like when we're doing an application problem, we'll use the number 3.14. The area of a circle is actually pretty tricky to define. How can we count the number of squares that would exactly cover a circle? Well, so here we have some pretty straightforward counting. The squares that are completely inside the circle, we could count those up. But what about this piece of the circle? How much of a square is this curved shape? And what about this piece of a circle? It looks like this part of the circle could be covered by a little bit less than 1 square, but how much less? It's kind of hard to know. Later on in your math career, if you take calculus, which I recommend, you may one day be able to prove this very easily. But for now, we're just going to believe that the area of a square is pi times the radius squared. Now, note the fact that there's a squared in this formula, and remember that we have been defining area in terms of a number of squares. This is not a coincidence. The fact that we use the word squared, that the radius is squared, and that area has to do with squares is all connected. And this can actually help you remember the formula for area if you think that area is about the number of squares that cover a given figure. Okay, we now have the following set of rules, and referring to this diagram, you can write down in your notes concisely this list of rules. We have that the diameter of a circle is 2 times the radius. In other words, the radius is 1/2 of the diameter. So these two equations are saying essentially the same thing. The circumference of a circle, the distance around the edge, is related to the diameter by this special number pi. This blue box that I've drawn indicates that this relationship is the most fundamental relationship we have when we talk about circles. Everything comes from this relationship. All of these formulas, this relationship here is sort of the mother of them all. Using this, we can rearrange this algebraically to the circumference is pi times the diameter. We get from here to here simply by multiplying both sides of this equation by d. We can also rearrange this equation by substituting instead of d, we can substitute 2r, and that gets us from this form of the equation to this form of the equation. We've merely substituted 2r instead of d. And then the area equation, as I've said, comes from calculus, and you'll just have to trust me for now on that one. Let's do an example problem where we're asked to complete this table, leaving our answers in terms of pi. Okay, we're given the radius of our circle. And the circumference of the circle is the first thing that we're asked to put into this table. So referring back to your list of rules, we have that the circumference is equal to pi times the diameter of a circle, or since we're given the radius, we want it in terms of r. So it's 2 pi times the radius. Now we can plug in the number that we've been given for the radius. So the circumference is going to be 2 pi times 6 times the square root of 2. Okay, how do we simplify this? We have a radical and we have pi in this expression, and we have two numbers. All of these things are multiplied together. So we can multiply 2 times 6, that's straightforward, that's 12. Next, we're going to write the pi, and last we're going to write the square root of 2. That's a convention, as I said in one of the other videos, so that we don't accidentally think one of these things belongs inside of this radical. We write the other things in front of the radical. So 12 pi times the square root of 2 is what goes in this circumference box. Now we're asked to find the area. Remember, our formula for area is pi r squared. So we'll plug in the number for radius here. So we have that the area is pi times 6 times the square root of 2, all squared. This is the tricky part. Remember that putting these parentheses here is key to getting this right. All of this is squared. So the 6 is squared, 6 times 6, and the square root of 2 is squared, so times the square root of 2 times another square root of 2. And then we still have our pi in front. So 6 times 6 becomes 36. The square root of 2 times itself becomes 2, and we still have our pi. So we have pi times 36 times 2, which gives us 72 pi. And we're leaving our answers in terms of pi. So 72 pi goes in this last spot in the table. You try one, complete this table, and leave your answers in terms of pi. In example 2, we're going to do something fairly similar, except now we're being given the area, and we have to sort of work backwards in order to find the circumference and the radius. So I'm going to start, since I have area, I'm going to start by writing down my formula for area. Area is pi times the radius squared. I'm going to plug in the number that I have for area. 50 pi equals pi r squared. Now, since pi is just a number, you may not be comfortable with this move yet, but I'm going to show you it because it's something that you're going to have to do. Dividing both sides by pi is a legal move, and it's a helpful move. Now we are left with 50 equals r squared, which is a solvable equation. We can take the square root of both sides of this equation, leaving us with the radius equal to the square root of 50. Now 50 is, in order to write this in simplest rational form, we're going to make a factor tree, and we're going to get the prime factorization of 50 is 5 times 5 times 2. So inside this radical, we have 5 times 5 times 2. Since we have a pair of 5s, they can come out of the radical, but there's only going to be one of them left. So 5 times the square root of 2 is our radius. I'm going to write that in the radius box. And now for circumference. Our formula for circumference is pi times the diameter, but since we have radius, I'm going to use the radius form, 2 pi times the radius. So that gives me 2 pi times 5 times the square root of 2. Again, these are all numbers being multiplied together, and I'm not going to plug it into my calculator. I'm going to simplify it. So 2 times 5, I can write in the front, 10. Then I'm going to write my pi, and last, I'm going to write my radical, the square root of 2. That's the one we write last so that we don't get confused thinking that other things are inside the radical sign. So 10 pi times the square root of 2 is my circumference. You try one like this. Complete this table, leaving your answers in terms of pi. Okay, now we're going to do a final example, and I'm going to ask you to guess before we actually do the math. If we have 6 ounces of pizza dough to make an 8-inch pizza, how much dough will be needed to make a 16-inch pizza? So notice that the diameter of the pizza is doubling. What's your guess as to what will happen to the amount of dough needed? Okay, now that I'm going to make a picture of the 2 pizzas, one with a diameter of 8 inches and one with a diameter of 16 inches, you might look at the picture and think, I might want to revise my guess, or I was right about my guess. So let's do the math and see what the real proportion is between the amount of dough needed for 8 inches and the amount of dough needed for 16 inches. First of all, I'm given a diameter, which isn't very useful when we're talking about area. So I'm going to write down that my radius is 4, and my radius here is 8. Now I can write down my area formula. Pi times the radius squared. Area over here is pi times the radius squared. I'm going to label these 1 and 2, R1 and R2, area 1 and area 2, so we don't end up thinking that these are the same variable. Okay, so my area 1 is going to be 4 squared is 16. I'm going to write that in front of the pi. Area 2, 8 squared is 64. I'm going to write that in front of the pi. And now that I have these 2 numbers in terms of pi, I can see that 16 pi times 4 is what's giving me 64 pi. So the area of the smaller pizza got multiplied by 4 to get the area of the larger pizza. And there's something pretty deep mathematically about this, because remember, area is in terms of, we think about covering something with squares. And the word squares is not a coincidence. We are multiplying the diameter by 2. When we multiply the diameter times 2, we end up multiplying the area times 2 squared. Two squared is our proportion, because area is about squares. You try this one. 1 can of pumpkin pie mix will make a pie of diameter 8 inches. If 2 cans of pie mix are used to make a larger pie, find the diameter of that pie. Notice that this is a little bit different from the last problem. Some hints for you are, draw a diagram, write down what's known and what's unknown, and try setting up a table like we did in the first 2 examples. For further practice, see page 448, 1 to 11 odd, 15, and 17.